Hi, today we're going to be doing a lesson about dilation and similar figures, a tutorial guide by me, Aaliyah, and my two partners, Didi and Destiny. The standards for dilations and similar figures are: describe the effect of dilations, translations, rotations, and reflections on two-dimensional figures using coordinates. Understand that a two-dimensional figure is similar to another. The second can be obtained from the first by a sequence of rotations, reflections, translations, and dilations. Given two similar two-dimensional figures, describe a sequence that exhibits the similarity between them.
First, we'll talk about dilations and scale factors. The definition of dilation is a transformation that enlarges or reduces the figure by a scale factor. And the definition for scale factor is the ratio of the lengths of two corresponding sides of two similar figures. Let's go do some examples. Here's an example for a scale factor. Over here we have two triangles. There is a green triangle and there is an orange triangle. In the green triangle, the points are 6 and 6 and 9. And for the points for the orange triangle, there's 24 and 24 again, and then 36. Here's how to solve the scale factor. We set up an equation in fraction form. We put 24 over 6, which also equals 24 over 6, which also equals 36 over 9. And if you divide all of these, 24 by 6 and then 36 by 9, you get the answer 4. That is your scale factor. Let's talk about similar figures. The definition of similar figures is when one figure can fit onto another perfectly by a series of transformations and dilations. Now let's do an example of similar figures.
Okay, here are two triangles of similar figures. As you can see, they have tick marks to show which angles are similar and which are not. As you can see, all the angles on the triangle are all similar. So, as you can tell, if the triangle on the left were rotated, then it will be rotated and slided, then it will be able to fit on the second triangle. So this is a example of similar figures.
Now we will show you a video on similar figures, and this is from LearnZillion.com, where you could register as a student and you could create a username and password, and you can watch videos and do lessons about and learn about math related subjects.
How do you know if A, B, C, D, and E, F, G, H are similar? In this lesson, you'll learn how to determine if two figures are similar by using a series of rigid transformations and dilations. Let's review. Rigid transformations keep the shape of a polygon and only change its orientation. So far, we've learned about three rigid transformations. The first one is a translation, which moves the location up, down, left, or a combination of any of those. The second one is a reflection, and a reflection flips the shape over a line of symmetry. The third one is a rotation. A rotation turns the shape around a fixed point. We've also learned about dilations. Dilations are transformations that create an image that is larger or smaller than the pre-image. Here we have triangle ABC. If we dilate that or enlarge it, we will have triangle A prime, B prime, C prime. The scale factor of ABC to A prime, B prime, C prime is equal to K, which is the image length divided by the corresponding pre-image length. In this scenario, that would be K equals C prime, B prime divided by CB equals A prime, C prime divided by AC equals A prime, B prime divided by AB. Let's begin today by talking about similar polygons. Similar polygons have the same shape but not necessarily the same size. In this diagram, triangle ABC and triangle DEF seem to have the same shape but not the same size. We can check that by starting with triangle ABC and doing a dilation or a reduction to make it smaller. And when we do dilate that, we know that the corresponding sides are in proportion. Therefore, all pairs of corresponding sides are proportional to each other. After we dilate it, we can translate it to the right and down. And in doing so, our new triangle will be right on top of triangle DEF. Therefore, all pairs of corresponding angles are congruent. And the scale factor for the ratio of the sides is going to be FE divided by CB equaling DF divided by AC equaling DE divided by AB, and the corresponding angle measure is angle A is congruent to angle D, angle B angle E, angle C congruent to angle F. The similarity symbol in geometry looks like this, and we can make what's called a similarity statement. Because these two triangles are similar, we can state triangle ABC similar to triangle DEF. A common misunderstanding many students have is when they go to write their similarity statement. The way you write your similarity statement is important. Here we have two shapes that are similar to one another, and we're told that in the diagram. And we want to write a statement stating they're similar. We can start at any vertex, and I'm going to start at vertex A of the bigger shape, and I'm going to go counterclockwise. You can go in either direction, but you need to go in order. So I have A, D, C, B. Now, when I go to write my similarity statement, that's going to be similar to the other shape, which I can write one of two ways. Starting at H, I could write it as HEFG, going clockwise, or going counterclockwise, I could write it as HGFE. Which one represents a true similarity statement? Since we have to match up corresponding angles, it's important we go in the same direction starting from the same vertex. So since I started from A and went counterclockwise, ADCB is similar to HGFE, starting at H going counterclockwise. Given triangle FGH similar to triangle JKL, we're asked to list all the pairs of corresponding congruent angles and write a proportion that relates all the corresponding sides. We can look at triangle JKL and triangle FGH, and we see they're not in the same orientation and they're not the same size. So let's start by dilating triangle JKL. We can make it larger, and in doing so we'll know that the sides are going to be proportional, and then we can rotate it to the right, and then translate it down and to the right. When we do that, all of our corresponding angles match up. And we can look at what angles are congruent in the similarity statement and in the diagram, and we see that angle F is congruent to angle J, angle K is congruent to angle G, angle L is congruent to angle H. And looking at the ratio of the corresponding sides, the K value is going to equal FG divided by JK, equaling GH divided by KL, equaling FH divided by JL. And the way they're written in their similarity statement helps us to match up our corresponding sides and our corresponding angles. If we need to determine whether these two figures are similar, and then calculate a scale factor and make a similarity statement, again, we're going to start with our first shape, A, B, C, D, E, and I'm going to start by rotating it to match up the corresponding angles, and then enlarging it. In doing so, we'll know that the ratio of the sides are congruent, and then I'm going to translate it up and to the right, and we see that the sides match up and the corresponding angles match up. In order to write a similarity statement and to find the ratio of the sides, we'll look at the K value. I'm going to start with the smallest sides in each. You can start at any side, but I'll start with the smallest and match up my corresponding sides based on my translations. So 3 divided by 2, that has to be the same as 3 divided by 2, which has to be the same as 3.45 divided by 2.3, which has to be the same as 3.45 divided by 2.3, equaling 3.75 divided by 2.5. We need to check each of these ratios to see if they are indeed equal. And they all equal 1.5, therefore the scale factor is 1.5. And when we rotated and translated, we saw that our angles matched up with one another. Angle O congruent to angle E, angle P congruent to angle A, angle R congruent to angle B, angle M congruent to angle C, and angle N congruent to angle D. And when I write a similarity statement, I'm going to start at O, and I have O, P, R, M, N. Starting, and that would be similar to E, A, B, C, D. And again, I matched up all of my corresponding angles and sides. In this lesson, you've learned how to determine if two figures are similar by using a series of rigid transformations and dilations.
Thank you guys so much for watching this video.
We hope this helped you learn dilation and similar figures. This is Destiny, Dee Dee, and Aaliyah signing out.
Goodbye!
Bye.